So we're going to get into chemistry. So we've already had our kind of first chem lab. I looked at some ions, kind of predicted the chemical formulas, and we came up with a name. So we're going to kind of go back a little bit. This is going to be more a review of your grade 9 chemistry. There are kind of a few big topics that we'll cover in the chem unit. So these first few, again, are going to be review. So like structure of atoms and molecules. We'll briefly look at some Bohr diagrams. Going to look at how to name compounds and formulas. Already started to work on this. Going to look at how atoms move around. So I'm going to give you like some different chemical formulas. We're going to predict what they'll turn into. We're also going to look at energy change in those reactions. Some reactions absorb a lot of energy, some release a lot of energy. It's going to do some looking at acids and bases. You've probably heard of acids before. Bases are almost the chemical opposites. And this will overlap a little bit with physics, but we're going to look a little bit at nuclear energy. Just to start out with, got a video for you. It's kind of a brief history of the atom. Kind of talks you through atomic history. So kind of pause this video, take a look at this video on the history of the atom, and then return to this video. All right, so these are now in your notes. These are just kind of a few of the key people in the development of atomic theory. So it started all the way back in 400 BC, this guy named Democritus. He is also involved with some philosophy on the idea of democracy. He was a philosopher and he just came up with a thought experiment. What is the smallest possible piece of cheese you could have? So if you started out with like a block of cheese, cut that in half, you cut it in half again, then again in half, and just keep going smaller and smaller. Like, is there kind of a point to that cheese where you can't cut it anymore? So it was entirely philosophical, just a thought experiment. He's kind of wondering what the smallest possible piece of cheese would be. So kind of call this the atomos, just the smallest tiny particle of matter. Next big development in atomic theory was a couple thousand years later in 1803 with John Dalton. So he said that atoms kind of basically look like marbles or kind of like pool balls. And that elements just kind of consist of like different marbles. And these marbles combine in different ratios to produce compounds. So this is the kind of first revival in atomic theory. Then at the end of the 1800s, we had this guy named J.J. Thomson. He did some more experimenting and he actually discovered the electron. He didn't really know where to put these electrons. He was still kind of working off that marble metal that Dalton came up with. So he just stuck these electrons on the outside of that ball. And it's called a plum pudding model. It's a kind of British desserts. Just kind of a bread with a bunch of raisins on the outside, or raisins or plums, and they called it a plum pudding. He said the electrons were kind of like these raisins, bread was like the ball. Then a few years later, we had Ernest Rutherford. There's a typo there, that should be Ernest, not Earnest. So there's an extra A in there. He discovered the nucleus. We kind of looked a little bit at his experiments on our first day of in-person classes with the gold foil. He shot those alpha particles at a very thin piece of gold. Some of them bounced backwards, so we reasoned there must be a very heavy thing inside of the gold foil to cause those alpha particles to bounce back. And it must be positive. It's kind of got an opposite or the same charge as those alpha particles. Next year, Niels Bohr came along and he said that there are electrons outside of the nucleus. So electrons are separate from the nucleus, and they kind of orbit around the nucleus. These electrons follow a fixed rule. So the first ring has only 2 electrons, next ring has 8 electrons, and so on. Then kind of after 1930 and on, we have the kind of quantum cloud model of the atom. So it's kind of where we're sort of at now. So this is kind of really emphasized by like Schrodinger. Might have heard of him before. So that the electrons just kind of exist in a cloud around the nucleus. Don't know exactly where they are. All we can estimate is a probability of them being in some spot in that cloud. So I'll kind of go over just a few key terms. Hopefully you know what an atom is. It's just the smallest particle of an element. It still has the same properties as all the other atoms of that element. If you have a lot of the same atom together, again, they're still going to have the same properties. And atoms are very, very, very tiny. If you take 50 million atoms and line them up, it'd only be about a centimeter long. So you can fit 50 million atoms in a centimeter long line. Also got a few different subatomic particles. So an atom is made up of protons, neutrons, and electrons. Atoms always can join together to form molecules. So a molecule is more than one atom that are being chemically combined. Molecules can either be elements or a compound. So if it's an element or an elemental molecule, it has 2 of the same element in that molecule. If it's a compound, it has at least 2 different elements in that molecule. So oxygen, O2, is an element. It's also a compound. Hydrogen, also an element and a compound. H2O is only a compound. We've got 2 different elements in there. So we've got this picture. Just take a minute, try and sort all of these dots, figure out whether they're atoms, molecules, compounds, or a mixture. All right, so here's the answer for that picture. Just kind of take a minute, review a bit, make sure you got everything right on there. Kind of uncertain on any of those, just let me know. All right, so we also have to deal with different types of change. So in chemistry, we're gonna be looking at chemical changes. Basically when the atoms themselves rearrange themselves into new arrangements. They kind of switch from being a compound with one type of elements to a compound with different elements. Usually chemical changes are not reversible, and they will make a totally new product. So there we've got a picture of an apple. One side's gone brown. It's been exposed to the air for a while. It has reacted with oxygen, undergone a chemical change. Middle picture, we have some toasts. One side's been toasted, the other side has not been. There's been a chemical change there just from heat being applied to the bread. Can't really reverse it. If you know how to untoast toasts, you kind of just let me know. All right, and just again, atoms are made up of smaller subatomic particles. So subatomic, smaller than the atom. Got proton, neutron, and the electron. Protons and neutrons are both hanging out in the nucleus, both relatively large. The electron is outside of the nucleus. The electron has a negative charge. proton is pro, has a positive charge, and the neutron is neutral. Got a couple of relative masses there. So proton, this is kind of in masses compared to electrons. So one proton weighs about the same as 1,836 electrons. One electron weighs about the same as one electron. Okay, so just again, like the nucleus is at the center of the atom. We've got our protons and our neutrons in the nucleus, both kind of bound together through nuclear forces. Electrons exist in that cloud around the nucleus. In a neutral atom, the number of protons will always be equal to the number of electrons. Also, this thing called a nuclear charge, which is basically the total charge inside just the nucleus. That nuclear charge is due to the protons. So it's going to be the same as your atomic number. So if we're looking at helium, it has 2 protons. It's going to have a nuclear charge of +2. Got our atomic number. So the periodic table is arranged by increasing atomic number. Atomic number is equal to the number of protons in that atom. Again, is always going to be equal to the number of electrons in that neutral atom. If you have a different number of protons, you can have a different atomic number. We're dealing with a different element. There are some cases where we can change the number of electrons, but still have the same number of protons. So we'll get a little bit more into that when we start talking about bonding. And our last number is the atomic mass. It's basically just kind of an average of all the known atoms of that element. So average number of protons plus the average number of neutrons. So for example, we've got like carbon. Carbon has 6 protons, and it kind of has an average mass of approximately 12.01. Carbon's always going to have 6 protons, but it can have different numbers of neutrons. So we'll get more into that in nuclear, or in our nuclear section. We're just kind of worried about, for now, its atomic mass is the number of protons plus the number of neutrons. So on your next page, got an example there of some bromine. Just give you a few minutes, try and figure out all the different numbers that would go and kind of describe this bromine. So what's the atomic number? What charge would a bromine ion have? What's the name? What's the average atomic mass? How many protons are there? And how many neutrons are there? Just take a few minutes and try and fill that out. All right, so hopefully you're able to figure that out. Got the answers here. You can just kind of double check your work. Our atomic number is 35. Forms a -1 ion. It's bromine. Average atomic mass is 79.9. Got 35 protons in there. And we have got 45 neutrons. When you figure out your number of neutrons, always round the atomic mass to the closest number. So in this case, we're rounding that 79 point up to 80. So total mass of 80 minus those 35 protons gives us 45 neutrons. All right, so we've got another practice table for you. Again, just take a few minutes and try to work through this. Let me know if you have any questions on it. All right, and again, here are those answers for you. It's kind of one thing to watch out for is that ion charge and the number of electrons. So if it's an ion, it's going to have a different number of electrons than protons. So with that potassium, it's a +1 ion. It's missing one negative thing. So it has fewer electrons than protons. If you have questions about that, again, just let me know in the meeting. All right, so I'm just going to kind of wrap things up with the organization of the periodic table. So we've definitely seen the periodic table before in grade 9. We would have seen it this week in class. All the elements are listed in increasing order of the atomic numbers. So metals are all on the left side of the periodic table. Non-metals are all over on the right side. And we've got these things called metalloids that form a staircase kind of off on the right side. So these metalloids kind of have intermediate characteristics between metals and non-metals. Got some properties of both. I had questions before about hydrogen. Anyone can figure out or tell me why hydrogen is over on the metal sides? That would be kind of cool. It does have some kind of unique properties to it. It is a gas, but it is over with the metals for a reason. Right, so with our periodic table, we've got periods, and we've got families. The rows going across the table are called periods. All elements in a certain period have kind of the same number of electrons in their rings. So in period 1, there is kind of one ring. There's only one real spot where the electrons can be. In period 2, we've got that first ring filled up. Starting to add our 8 electrons into that second shell, and kind of fill up the shell going towards the right. So our period number is going to tell you how many rings are around that nucleus. Every time you get to a new row in the periodic table, you're going to reach a new shell. Also got organization going vertically. So we've got our groups or families going up and down in the periodic table. Every element in a group or family has similar properties, bond with other elements in similar ways. So we've probably seen all of these groups before. So our group 1, got some alkali metals. Group 2, we've got alkaline earth metals. They'll have similar properties. So with our alkali metals, they're all highly reactive metals. They have 1 valence electron. Alkaline earth metals have 2 electrons. They're slightly less reactive, but they all behave in similar manners. Over on the right side, we have the halogens. Again, these are all highly reactive nonmetals. Can be either gases, liquids, or solids going down the periodic table. And we've got our group 18, or the noble gases, over on the far right side. So these gases do not like to react with anything. There are conditions where we can make some of them react with fluorine, but those are kind of under very particular laboratory conditions. I've got another video for you. This one's on the kind of creation of the periodic table. Take a few minutes, watch through it. Let me know if you have any questions. We'll be posting another kind of chemistry assignment for you. If you have questions about that, you can let me know in the meeting.